Welcome back, and we're continuing sorting out that problem that we started with. We've calculated the initial momentum. We found it to be 28,000 kilograms meters per second. Let's come to the next question that says find the final momentum of the car. So P final should be equal to mass times V final. That should be equal to 1400 times V final. We found it to be 5.56 meters per second. We can also work that out quickly. We've got 1400 times 5.56. Okay, and the answer is 7784 kilograms meters per second. This is in the direction of motion as well. Even the previous one is in the direction of motion because it's in the direction in which the car is moving along that straight road. Okay, now if I am to find the change in the momentum of the car, change in momentum of the car should be equal to P final minus P initial. That should be equal to what was P final, 7784 minus P initial, 28,000. So we work that out quickly. It's 7784 minus 28,000. And what is the answer? The answer is minus 20,216 kilograms meters per second. This is the change in momentum. Therefore, this change in momentum is 20,216 kilograms meters per second in the opposite direction. In the opposite direction. Why am I saying so? Because I've calculated and find that assuming that as we did in our calculation, the direction of motion was taken to be positive. Now, if we calculate for momentum and find it to be negative, it means momentum is acting in the opposite direction of that motion. Okay, so that's what that negative means there. Okay, we also need to know, like we have seen in this calculation here, that change in momentum can occur in the opposite directions as well. Okay, let's look at a situation here where we have a tennis ball of mass 0.05 kilograms moving at 4 meters per second towards the wall. It collides with the wall and rebounds at 2 meters per second. Determine, let's have a look at the momentum of the ball before it hits the wall. So P initial should be equal to mass times V initial. Mass is 0.05 times V initial is given to us as 4 meters per second and V final is 2 meters per second. But what we need to know in this is that we need to assign directions here. Let's say we say towards the wall is positive. So this times velocity initial, which is 4 meters per second, it has to be positive because towards the wall is positive. So 0.05 times 4 gives us 0.2. So this is 0.2 positive kilograms meters per second. This means towards the wall. It's positive. Now, the next one, find the momentum of the ball after colliding with the wall. After colliding with the wall, P final equals mass times V final. So mass is 0.05 times, what is V final? V final is 2.5 meters per second away from the wall. So away from the wall, therefore, has to be positive because towards the wall, we took it to be positive. So away from the wall has to be negative. I think I must have said it incorrectly there. So 0.05 times negative 2.5 because this is away from the wall. Okay, so 0.05 times negative 2.5. Okay, and your answer is what? Negative 0.125 kilograms meters per second. Okay, now the next one says find the change in momentum of the ball. Now what we need to do here is we know P, change in P equals P final minus P initial. So what was P final? P final is minus 0,125. Minus 0,125 minus that minus there. What was the initial momentum? 0,2. Okay, minus 0,2. And what will that be? This gives us minus 0,325 kilograms meters per second. What does this mean? It means that this change in momentum is in the opposite direction. So what we need to do is to say the change in momentum is 0,325 kilograms meters per second in the opposite direction. Okay, direction, or the best way to can say it is just to say away from the wall, because here you are told about the wall here going towards and going away from the wall. So if you don't want to say that, you can say away from the wall. Right, that's all I had for you for lesson number 34. This is Tinyiko Costa signing out. Bye-bye.